6.5, solving equations containing rational expressions. So we're going to have to do some changing up here. I forgot to change that. To solve an equation containing rational expressions, the first thing we're going to do is factor everything and simplify. Cancel out step 2 and go ahead and pause it and just write what I replaced. Go ahead and rewrite that. Alright, so step 2 is to multiply every numerator by the LCD. Solve accordingly. We're gonna check the solution with the original equation. Alright, we don't have to work with fractions when we're solving. It's so great. I mean, I love fractions, of course, but they start to get a little annoying. I get it. But when there's an equal sign, when it's an equation, there's an equal sign. And when there's an equal sign, you don't have to work with fractions. I'm going to teach you how to get rid of them, okay? So let's learn how to do that. All right, so step 1 is to factor everything. So, I mean, everything is factored. I can't do anything with it. All right, now I need to find the common denominator. So, and you notice I'm saying common denominator. I don't care about the LCD. Just find the common denominator. You can use 12. You can use 12x. You can use 6x. You can use 18x. Now, it doesn't matter. They're all denominators that work. I'm going to use just the foolproof. Don't even think about it. Make my life easy. 3x times 6, 18x. Awesome. That's what I'm going to multiply everything by. I don't care about 6x. I don't care about 12x. I'm just going to multiply them together. Works every time. With an equal sign. Equal sign. All right, so I'm going to multiply everything by 18x. So we have 18x over 1 times 5 over 3x. And I did 18x over 1 because we're talking about a fraction right there. So plus 18x times 1. There's no fraction right there, so I don't need to put the fraction bar. And that equals 18x over 1 times 7 over 6. Now we're going to cancel out diagonally. So 18 divided by 3, we're left with 6. X and x cancel. There's no fraction. 18x times 1, it is what it is. And then 18 divided by 6, we're left with 3. That's all we can cancel. So let's write what we have left over. We have 16 times 5 plus 18x times 1. Let's just make that 18x. And that equals 3x times 7. Let's simplify. So 6 times 5 is 30. Plus 18x equals 3x times 7 is 21x. Let's solve for x. So I'm going to subtract 18x over. And when we do, we're left with 30 equals, so 21 minus 18, we get 3x. Divide by 3. And we get 10 equals x. On the paper notes that are on Canvas, I used the common denominator 6. And you're going to see we still got the same exact answer. Or, excuse me, the common denominator on the notes were 6x. Still the same answer. Doesn't matter how you do it, it works. Works every time. Alright, so that's the possible answer. Possible. We have to check it. You always have to check your answers. So let's check it. I'm going to do it in pink. So let's check. And our possible answer is 10. So we're going to plug it in. We have 5 over 3x, which is 10. That's plus 1 equals 7 over 6. So let's simplify here. We have 5 over 30 plus 1 equals 7 over 6. So that means 5 over 30 plus 1. So 1 is just same number over same number. So if the denominator is 30, it's 30 over 30 equals 7 over 6. So 35 over 30 equals 7 over 6. We can simplify because we can divide by 5. And when we do, we have 7 over 6 equals 7 over 6. That works out. So our answer is indeed 10. And yes, you do have to put the squigglies. The squigglies are called braces. All right, let's keep going. All right, first things first, we need to look and see if we can factor. So 1 over 2x, nope, can't do anything there. Minus 1 over x plus 1, nope, I can't factor x plus 1, that just is what it is. I can factor the bottom, though, here. I can take a 3x out. So if I take 3x, so if I take a 3 out of 3, I'm left with 1. And if I take x out of x squared, I'm left with x. Plus, if I take 3x divided by 3x, we're left with 1. Alright, so we factored our denominator. Now that we factored, we can go ahead and find our common denominator. So let's talk about the numbers first. So 2 and 3. So 2 times 3 is 6. And see how they share an x? If you have pairs, don't write it twice. If there's a pair, only write it once. So there is a pair, we only write it once. And then we have another pair of x plus 1. So since there's a pair, we only write it once. So that is our common denominator. We're going to multiply everything by 6x, x plus 1. So we have 6x, x plus 1 over 1 times 1 over 2x. And that's minus 6x, x plus 1 over 1 times 1 over x plus 1 equals common denominator times 1 over 3x, x plus 1. All right, now we're going to cross multiply. So left to right, we can do 6 divided by 2 is 3. We can cancel out those x's. Here we can cancel out x plus 1, x plus 1. 6 divided by 3, we're left with 2. X cancels out x. X plus 1 cancels out x plus 1. All right, let's write what we have left over. So we have 3 times x plus 1 minus 6x equals 2. We're going to distribute. So 3x plus 3 minus 6x equals 2. Combine like terms. So negative 3x plus 3 equals 2. We're going to subtract 3 to both sides. And when we do, we're left with negative 3x equals negative 1. Divide by negative 3. So we get x equals positive 1/3. Possibly positive 1/3. So we have to check our answer. All right, so we have our possible answer of x equals 1/3. Now we have to check our answer, and you're probably like, I don't want to plug it into there. I don't blame you. And guess what? You don't have to. You know what you can plug it into? This one right here. Yeah, you can. You can plug it into there. It's equivalent form. Do you know all we did when we multiply by the common denominator, we're not getting rid of the fraction, we're just moving it. We're switching it to multiplication. We're doing the inverse, the opposite. And we're allowed to do that because we're doing it fair. It's fair across the board, left and right side of the equation. So we know that 1 over 2x minus 1 over x plus 1 equals 1 over 3x squared plus 3x. It's equivalent to 3 times x plus 1 minus 6x equals 2. So we are going to plug it in to the first one when we got rid of the fractions. So once you get rid of the fractions, you can actually check with that equation. So the equation itself, I'm going to rewrite it. It's 3 times x plus 1 minus 6x equals 2. And remember, x is possibly 1/3, so let's plug it in. So 3 times x, which is 1/3, plus 1, minus 6 times x, which is 1/3, equals 2. We're going to distribute. The reason why we're going to distribute, you'll see when we do it. So 3 times 1/3, that cancels out, so we're left with 1. 3 times 1 is 3. Minus, so 6 times 1/3, so 6 divided by 3 is 2, equals 2. Combine like terms, so 3 plus 1 is 4, and 4 minus 2 is 2. So this does work out. Our solution is indeed 1/3. Do not forget to check your answers. I promise you later in this video, you're going to see that if we didn't check your answer, it would have been wrong. All right, let's keep going. There are two ways that we can do this. On the paper notes, I used common denominator. I'm going to show you a different way. So when you have one term equals one term, like we do, you see how it's one thing equals one thing? We can cross multiply. We're allowed to do that. That doesn't change. Although, like, we're working with nothing to do with proportions. Proportions are just fractions that equal each other. So when we have one thing equal one thing, so no plus anything, no minus anything over there, it's just one thing and one thing, we can cross multiply. So we cross multiply here, 1 times x plus 1 equals, now we cross multiply here, 2 times x minus 1. Yeah, we can do that. Isn't that so freaking awesome? Yes, I know. Awesome, right? So we have x plus 1 equals, we're going to distribute the 2, 2x minus 2. If you use the common denominator, you'll eventually get to here. It's just a couple more steps. The paper notes show you common denominator. So let's keep solving for x. I'm going to subtract x to keep it positive. So we're left with 1 equals x minus 2. Add 2 to both sides. And we have 3 equals x. Possibly, right? Possibly. We don't know for sure. So let's check. So let's check. You have to check yourself before you wreck yourself, right? Yep, I did it. All right, so let's check it. Do we have to plug it into the fraction? No, we don't. We can plug it into here. Although plugging it into this fraction is not too hard, right? It's not too difficult. So let's plug it in. We have x plus 1 equals 2 times x minus 1. And our possible solution is 3, so let's plug it in. All right, we have x plus 1, so 3 plus 1 equals 2 times x minus 1, so 3 minus 1. Let's simplify. So 3 plus 1 is 4, and then we have to simplify parentheses first, so 2, and then 3 minus 1 is 2. 4 equals 4. It does indeedy. So since it does equal 4 equals 4, our solution is 3. Don't forget the little squigglies. Alrighty. Next one. If you ever need more practice and more videos, you know what you can do. Go to Google and Google what we're doing. So you know how we're solving rational equations? So literally Google that and put Khan Academy afterwards. So what I would do is like, so if I needed more help, I'd see solving rational equations. Khan. Literally, that's what I would Google, and videos will pop up for you. So if you need more practice and more videos, and you need more examples, and my videos, you're rewatching them, and you're like, I just need more videos. That happens. Google whatever it is and put Khan afterwards. And those are great videos. Khan Academy is one of the best math websites, just learning websites ever. All right, let's keep it going. All right, our favorite F word, fractions and factoring. So let's factor 12. Really can't taste just 12. We can factor the bottom, though, because that's a difference of squares. It'd be 3 minus a, 3 plus a, plus 3. 3 plus a is just 3 plus a. And then equals 2 over 3 minus a. So we just leave that because it's 3 minus a. All right, now we need to find our common denominator. So let's look for pairs. We have a pair, 3 minus a, 3 minus a. Do we have any other pairs? We do, 3 plus a, 3 plus a. There's nothing left in my denominator, so that is my common denominator. We're going to multiply everything by 3 minus a, 3 plus a. So 3 minus a, 3 plus a, over 1 times 12 over 3 minus a, 3 plus a, plus common denominator, times 3 over 3 plus a. And that equals common denominator times 2 over 3 minus a. All right, let's start canceling. So we can cancel out 3 minus a, 3 minus a, 3 plus a, 3 plus a. We can cancel out 3 plus a, 3 plus a. And here we can cancel out 3 minus a, 3 minus a. So let's write what we have left over. We have 12 plus 3 minus a times 3 equals 3 plus a times 2. So we have to distribute. Remember, PEMDAS first, so distribute because of parentheses. So 12 plus 3 times 3 is 9. Negative a times 3 is negative 3a equals 2 times 3 is 6. 2 times a is 2a. Let's combine like terms where we can. So 12 and 9, we can combine those to 21 minus 3a equals 6 plus 2a. I'm going to add 3a to keep it positive. So we have 21 equals 6 plus 5a. Subtract 6 over to get a by itself. And when we do, we're left with 15 equals 5a. Last but not least, we divide by 5. So possibly 3 equals a. Don't forget, we got to check it. So let's check it. All right, so we have our proposed solution, 3. So now we need to check it. So what if you forget that you can check it using an equivalent form? What if you do that? So let's check it using the original equation. Let's do that. Let's just check it. I want to show you how to get comfortable with fractions, because sometimes we forget things. So like, what if we forget and we have, our mind goes blank? Just plug it into the original one. So let's plug it into the original one, which is 12 over 9 minus a squared. So 3 squared. And that's all plus 3 over 3 plus a, which is 3. And that equals 2 over 3 minus a. So 2 over 3 minus a. Again, that's 3. So let's simplify here. So we have 12 over 9 minus, so 3 squared is 9, plus 3. 3 plus 3 is 6, equals 2 over 3 minus 3 is 0. That weird. We don't even need to keep going. Why? Why do we need to keep going? That one right there. You can never, ever, ever have 0 in the denominator. Why? Because it's impossible. Why is it impossible? I will tell you exactly what happens when dividing by 0. Like, what happens mathematically when the universe divides by 0? You get a black hole. I'm not kidding. You really do. Look it up. Look up, divide by 0, black hole. That is literally what's happening. So that's why it's impossible. Like, something really bad happens to the universe. So it's like not good to create that type of gravitational pull and stuff like that. Anyways, because we have 0 in the denominator, we automatically can say, nope, 3 does not work, no solution. No solution. See why you got to check your answers? Right there. Yep, so don't forget to check your answers because sometimes they don't work. They're called extraneous solutions, and we'll talk more about them later through the semester. Okie dokie. All right, so factor. So top is just x plus 2. Bottom, we can factor that into x plus 5, x plus 2. All right, we can keep factoring, so we can take out 3, and when we do, we're left with x plus 2 minus 1 over x plus 5. Can't do anything there. So after we factor, because we haven't had to do it, let's go back up. Simplify if you can. And we can here. We can simplify because we can cancel out x plus 2, x plus 2. Top and bottom, you can cancel out willy-nilly like that. So what we have left over is 1 over x plus 5 equals 1 over 3 times x plus 2 minus 1 over x plus 5. Now we can go ahead and find our common denominator. So our common denominator, let's look for pairs. So we do have a pair, x plus 5, x plus 5. All right, let's see what else we have left over. We have a 3 on the outside. And then last thing, x plus 2. So we're going to multiply everything by that common denominator. So we have 3 times x plus 5 times x plus 2 over 1 times 1 over x plus 5. And that equals our LCD. Times 1 over 3x plus 2 minus LCD times 1 over x plus 5. All right, so let's start canceling left to right. So we can cancel out x plus 5, x plus 5. We can cancel out 3 and 3. Also x plus 2. And then last we can cancel out x plus 5. So writing what we have left over, we have 3 times x plus 2 equals x plus 5 minus 3 times x plus 2. That's all we have left over. We don't count the ones. The ones, they just put them, they go away. All right, now that we got rid of the fractions, we have to distribute. So 3x plus 6 equals x plus 5 minus 3x minus 6. So we're going to combine like terms where we can. So we have 3x plus 6 equals x minus 3x is negative 2x. Positive 5 minus 6 is negative 1. We keep simplifying, so I'm going to add 2x over. And when we do, we have 5x plus 6 equals negative 1 minus 6 over. So 5x equals negative 7. We're going to divide by 5. So x is possibly negative 7 over 5. Now let's see if it works out. So we got to plug it back in. We can plug it back into the original, or we can plug it back into this equivalent form. I'm plugging it back into the equivalent form, which is the, we're checking. It's the 3 times x plus 2 equals x plus 5 minus 3 times x plus 2. So let's plug it in. It's negative 7 over 5. So we have 3 times x plus 2 equals x plus 5 minus 3 times x plus 2, and that x is negative 7 over 5. All right, let's simplify the parentheses first. So we have 3 times negative 7 over 5 plus 10 over 5, because 10 divided by 5 is 2. You should know how to switch fractions. And then we have negative 7 over 5 plus 25 over 5. 25 divided by 5 is 5. Minus 3 times negative 7 over 5 plus 10 over 5. 10 divided by 5 is 2. Let's combine like terms in the middle. So we have negative 7 plus 10 is 3 over 5 equals negative 7 and 25. So negative 7 and 25 is 18. I don't know why I said that as a question mark. It is 18. I don't know. And then we have minus 3 times 3 over 5. So let's keep it going. We multiply straight across. And we have 9 over 5 equals 18 over 5 minus 9 over 5. So 9 over 5 does equal 9 over 5. That is a solution. So we can say negative 7 over 5 totally works. All right, last one. Last one, I want you to pause this video. It is for you to try. Be careful. Be careful, okay? That it's going to be a tricky answer. It's similar to this one. All right, so go ahead, pause it, try it on your own, okay? All right, hopefully you paused it and tried it. If not, do it. Okay, let's do this now. Factor. Can't factor x minus 3, it's just x minus 3, but we can factor x squared minus 3, or x squared minus 9, because that's x minus 3, x plus 3, difference of squares. All right, our common denominator, let's look for pairs. So x minus 3, and then whatever's left over, x plus 3. So we're going to multiply everything by our common denominator. So we have x minus 3, x plus 3 over 1 times 10 over x minus 3. And that equals our common denominator. Times 60 over x minus 3, x plus 3. Let's cancel left to right. So x minus 3, x minus 3. X minus 3, x minus 3. X plus 3, x plus 3. Now I'm going to write what we have left over. I'm going to bring it over here. So we have x plus 3 times 10 equals 60. All right, we're going to distribute. So 10x plus 30 equals 60. Subtract 30 to both sides. So we have 10x equals 30. Divide by 10. X is possibly 3. All right, so we have our possible solution of x equals 3. So you can plug it in. You can plug it in into the original equation, simplified version, or there's something that we can do. Now, I'm only going to show you on the last one. It's up to you. We can check it with the domain. You know how to find domain of a fraction. We've already learned that. Remember, the domain of a fraction is a denominator can't equal to 0. So each denominator that we have, it's x minus 3 and x plus 3. Those are all the denominators, right? It's either x minus 3 or x plus 3. So we have x plus 3 cannot be 0, and x minus 3 cannot be 0. So x cannot be negative 3, and x cannot be 3. So you see how x cannot be 3? This is a no solution. That's another way we can do that.